I am joined here by my professional assistants. Well, Miller, I mispronounced his name, and Cole Meyer, and Seth Perry, who does not want to be in the video, as well as Steve Baker, who is holding the camera and also does not want to be in the video.
Oh, that looks wrong.
We are going over day 4
What are you doing?
of our 20 days to STAAR, and we're going to start with question number 1, which Cole is going to do for us. Awesome.
Write an equation which expresses circumference if the radius is 4 centimeters.
Okay. So, Joel, you have in front of you a math chart, and it's asking us for circumference with the radius in it. So which formula would we use?
We would use C equals pi times diameter.
Okay, but which one has radius in it?
C or 2 times pi times radius.
Oh, 2 times pi times the radius. And, well, what are we going to substitute for the r here?
4.
4. Okay, so if we rewrite this with 4 as our radius, then we would bring this down to pi and a 4 instead of the r.
Okay.
So can we simplify this in any way?
Yes.
We sure can. What would we write?
We would write 4 times 4 equals
16.
416 times 2 would be 32.
How come you're multiplying times 4?
Because it's the 4 times itself. Oh, no, I'm just kidding.
That's only when you're doing
You
area.
would times this way, that times that.
Okay, so if we multiply 4 times 2,
Okay.
we would have the circumference is equal to 8
8 times r.
r, which is also known as pi. And write an equation, which, okay. So it
Go ahead,
doesn't
go ahead.
say that we have to use 3.14, so we can just leave it as this. Circumference
Boom!
is
That's
equal
how you
to
do it.
8 times pi.
And you know what? Since we got this
then-
right,
Can you move? Can you move?
We ready? All right. Question number 2, Cole.
we're back with Cole.
A
What do you got for
number
us?
cube has 6 faces numbered 1 through 6. Mr. Reed had one of his students come to the front of the classroom and roll the numbered cube 50 times as the class recorded the results in a frequency table. What was the percentage difference between the experimental probability and the theoretical probability results, terms of rolling and all that?
Okay.
Now with the other guy.
Okay, so we're going to figure out the experimental probability of this and the theoretical probability of rolling an odd number. And when we do that, we're going to after we're finished doing that, we're going to compare them by figuring out the percentage difference between them. So, what's the probability of getting an odd number theoretically?
Well, if we're gonna roll a number cube die, that means it would be 2/3.
2/3?
2/6.
Okay, so how many sides are there of the dice?
There's 6.
There's 6, so our total possible outcomes is 6. And
1,
how many of those are odd?
3.
3 of them are. Okay, so if we were to simplify this, what would the probability be in theory?
1/3.
3/6. What is that?
36.
3/6. Divide the top by 3 and the bottom by 3. What do you get?
1/3.
What's 6 divided by 3, Joel? 1/2. Okay.
See, I'm learning.
Glad that's on video, right?
Yeah.
All right. So 1/2 is the theoretical probability. And then we're going to figure out the experimental probability. So we have 50 as our possible outcomes
Oh yeah.
for theoretical. And then for our odd outcomes, we had 6 ones rolled. We had 9 3s rolled.
And 5 9s.
9 5s rolled. Don't say it backwards, you'll get us all confused. Okay,
Like
so
STAAR.
9 plus 9 plus 6 is our positive
What do you want?
outcomes. And if we add that all up, we get 24 out of 50.
And then we would multiply it by 1/2, right?
No, we're gonna find the percentage difference.
Oh, okay.
The difference means that we're going to,
Divide that by that.
okay, but if we wanna find the difference between 1/2 and 24/50, what are we gonna do? Subtract, okay? So, let me label this as our experimental probability. And whenever we're finding the difference between two fractions and we're subtracting fractions, what do we have to do? What do we have to do? Can we subtract 24/50 minus 1/2?
we have
or the other way
to-
around?
We have to get a common
We have
denominator.
to get a common
So
denominator.
then what we're gonna do is we're gonna multiply this by 1 and multiply this by 20.
Very good. So what would that be as a fraction with a denominator of 50?
It would be this, Miss Paige.
Okay? So let's write them the other way around with the 25 on this
Okay.
side. Okay. All right, so we're doing 25/50 minus 24/50. What's the difference?
150.
1/50. And if that is our difference as a fraction, we're going to change that into a percent.
We would divide that by that. So that means if we get 1 and 50, add the decimal, 0 and 0. 50 goes into 100, of course, 2 times, add the zeros. There you go.
Okay? So
It would be
what percentage is that?
20%.
You moved your decimal over,
Oh,
yeah, you moved your decimal over too many places. Only move it over 2. What percentage would it be if you only moved it 2? 2%. That's right. So it's only a 2% difference. Another way that you could do this that's more simple is to remember that if you have a denominator of 100, the numerator is actually a percentage. So if I multiply this times 2 and this times 2, I get 2 100ths, and that's another way to get 2%.
That's amazing.
That is amazing.
Like,
I'm
can
glad
you-
you agree.
Can you multiply times 2 every single time? Because what if you get like 2/50ths? What do you do? Multiply times 2?
As long as the denominator is 50, you can multiply the numerator and denominator by 2, and that will give you a percentage.
So when the denominator is 50, multiply by 2 and you'll get your percentage.